expectation is for these problems, okay? So the first one we'll do is the first one on there, number 10, from 2002. Remember, that's a long time ago. I know, some of you weren't even born then. Okay.
What? How old do you think we are?
Babies. Just babies in my eyes.
Maybe your son.
What year was that?
2001. Yeah. Okay, so we have f of x equals 3x plus 2, g of x equals 6 over 2x plus 3. Let's look at what the way it's written. I rewrote it with what we're familiar with, and rather than f dot dot x, etc., I did the f of x and g of x. Okay, so don't be alarmed by that. What does that little symbol to the side of it mean? X is an element of the reals.
All real numbers.
What is all real numbers?
Negative infinity to infinity.
Right, and the domain. That means the domain are all real numbers, right? So they're telling you that everything's good to go for this, you know, as far as domain is concerned. Okay? Now let's move on to the next one. It's x is an element of the reals, except x cannot be negative 1.5. Does that make sense? Because the denominator can't be 0. That's right, exactly right. So it says everything is cool except for the one thing that makes that denominator be 0. So that's why they put that there. Some people get really kind of like nervous when they see that language there. And it's really just meant to help you remember, you know, what the domain is, or are there any hiccups in the graph. Okay, are we good?
What does it look like when you graph it? Just a regular shape and just a hole?
These kind of guys typically look like that type of graph. It's not that exactly because it's shifted to the left, negative 1.5. That's called an asymptote. Okay, and so what that is you have something happening on the left and the right. I'm not saying that that is the graph of that. I'm just saying typically that's what happens with those.
So the thing that you can't have x be would be the asymptote because it's
Correct.
something it never reaches.
Correct. So your normal one, you know, at the end of class we'll go over. I'll bring up the Desmos thing. You guys are familiar with Desmos? Desmos is a graphing calculator you can look at and kind of maneuver it and see what happens. And we'll do one, just a basic one, like 1 over x, okay? What would the domain of that guy be? It would be all real numbers except 0. So the asymptote here would be 0, which is the graph I just drew. It would look a lot like that. Okay, so we'll kind of look at that. It's just a shift of those things. But having said that, we're going to kind of look at these two and see, are we able to do this problem? So, first of all, it says, find the value of x for which f g x equals 3. Okay, so it's asking me to solve for x, and it wants me to do f g x equals 3. We started to work on that yesterday. We did a couple problems like that. What does the f g x indicate that we have to do?
Plug in g into
plug g into f, right? So this guy stuff gets plugged into this stuff. It's called composition. Yes?
So if there's no number in place of the x, you just put the first equation in this, the second
Correct.
equation in the first.
Correct. If there's a number there, the way you start is you plug the number in, then you take that number and stick it in there.
and you get the
Okay.
Yeah.
function.
Keep going and plugging and plugging and plugging. So in this particular case, we're just taking this guy and sticking it in here.
So you stick that
And then you-
Right. So this thing becomes the x's of that graph.
So then you make the whole like the one equation equal to 3.
Correct. So your whole new equation is going to be 3 parentheses 6 over 2x plus 3 parentheses plus 2 equals 3. Okay, so hard or not hard? I think pretty fairly decent. I think looking at the initial problem, it might look a little intimidating, fractions involved, but I think once you see what's happening, you're like, oh, this makes sense, it's not too bad. Okay, so now what do? We go back to the algebra skills that we own. So we're going to get rid of the 2, right? Let's just do it slowly. When we subtract 2 over here, we get the number 1. So far, so good? Are we good so far? Yeah? We're close? We're close to being, yeah? Okay, good. I see you. Now, there's a couple ways that we can handle this problem. I could divide both sides by 3 and have a fraction equal to a fraction. I could multiply the 3 in and get 18 over that equals 1. You guys choose.
So when you distribute the 3, you don't do it to the numerator.
Correct, because this is really 3 over 1. Yeah? So, yes.
So, but if you made it so that there's fractions on both sides, would you need to cross multiply?
You could cross multiply.
Mm-hmm.
You could do that. You could do that anyway. Yeah. So there's a couple ways that you can do it. Let's do that. Let's do 3 times 6 is 18. Now that we recognize it only goes to the top, and then we have 2x plus 3 on the bottom, and that's equivalent to 1. Right, because I'm frightened by fractions. I'm going to multiply that guy over there. Really, it's like cross multiplying. So 18 equals 1 times that stuff. So 2x plus 3, right?
Mm-hmm.
It's easy enough. I'm going to subtract, and so I get, what, 15 equals 2x. X equals 15 halves, or
17 or 7.5.
Yeah. So are we comfortable? How many points did we earn?
3, 4. Yeah, 3.
Find the value of x, 3 points. Not bad, right? Okay, so the next thing says, and okay, so remember this is back in 2002. Things have changed a little bit. This particular one says sketch the graph on a single diagram. So they're going to give you graph paper, and they want you literally to graph, in this case, f of x, this thing, and they want you to graph this. What are they asking you to do? The inverse, right? So what would that entail? It would entail me taking this, finding its inverse, and then graphing both of them. And then, here's the important, make a clear relationship between the two graphs. What does that mean? Label them. It's very important to label them. That's all they're looking for there. So let's go ahead and practice how to find the inverse. So I'm going to get rid of this here. And so we have f of x, and we want to find its inverse. So step 1 to finding the inverse of it is to label it as y instead of f of x. So y equals 3x plus 2. Now what's step 2?
Flip the x and y.
Flip, interchange, flip, or interchange. Good job. So we have 3y plus 2. Everybody comfortable so far? And nice of them to give me a linear one. I'm not having to worry about fractions or factoring or any of that fun stuff. So I'm going to subtract 2 and divide by 3. Oh. So somebody's at the door. Do you mind getting it? Thank you. So x minus 2 divided by 3 is y. Hello. Okay, so now we have that. And so what are we going to do? We're actually going to call it the inverse. So the inverse is x minus 2 over 3. Come on up. Oh, cool. Yeah, that's okay. So then it says it wants us to draw it with a clear distinction. Now, it probably wouldn't hurt us to review how to graph something. We don't do that a whole lot in here. What do they want us to do when they want us to graph if we're looking at this? Well, for me, I see 3x plus 2 as not much of a challenge. I don't really need a t-chart for that. I think I could just plot the y-intercept and then worry about the slope. Everybody on the same page? Okay, so let's do that just so we can see. Just as a little review. Because, again, this is in 2002, and I haven't seen that happen a whole lot, where they make you graph them, and clearly just it wouldn't hurt to practice. So we have our perfect graph. Remember, you will have graph paper, okay? A little different than what we got going on here. Okay, so it wants us to graph 3x plus 2. So I'm going to plot the y-intercept first, and then rise over run. So up 3 over 1, up 3 over 1, or down 3. Right, 1, 2, 3, backwards 1. These eyes aren't working very well. And so we should have what we call a straight line. So close. There it is. Okay, so we have f of x equals 3x plus 2. Clear distinction. Does yours look as good as mine?
Better.
Oh, what? Better. Okay, whatever.
Just kidding.
So now what we're going to do is we actually have y equals x minus 2 over 3. And if we have a couple options. We can break it up into y equals mx plus b. It would look like this. y equals 1/3 x minus 2/3. Remotely familiar? Okay. Or we could do a T-chart. It's up to you. However you want to do it. If we did this,
Easier, right?
the T-chart,
Yeah.
could be easier.
T-chart's easier?
Either way, like this guy, I'd have to go down to 2/3. So I'd have to come down 2/3, which is about right here.
Yeah.
And then I'd have to go up 1 over 3. So I would have to come up 1 and then over 3. 1, 2, 3. And then up 1 and then
like
over.
yeah.
So it's not really pretty. 1, 2, 3. Nor is the actual graph itself, but you got the idea. Or you could do a T-chart. You could do the x and the y, plug in some points, and then plot your lines. You could also, desperation mode, let x be 0, solve for y. Let y be 0, solve for x. Get 2 distinct points, and then graph that. Okay, remember, it's from 2002, so they haven't done that in a long time, but you know, this could be the year. Okay, so
That'd be great.
it would be really nice if they did that. There's almost, okay, so anyhow, yeah, beautiful. So distinct, and see, I think that's part of the problem is they give you that funky graph paper. So they want you to clearly distinguish between the two. Again, you'll be using a ruler. Yes.
Oh, so 1/3 x minus 2/3. You're just rewriting x
I
minus 2
did. I
over 3.
recognize that they both have that same denominator, so why not make it 1 out of 1 over 3 minus 2 over 3.
Mm-hmm.
Okay, so that was worth a whopping 3 points. Now let's look at the next one. Express each of the inverses of f to the negative 1 and g to the negative 1 in terms of that. And then solve. F inverse equals g inverse. Okay, so they want me to actually solve. F inverse equals g inverse. Well, we've already done part of the work. We found F inverse. So what would we have to do for g? Find its inverse. Okay, so let's go through the process. Let it equal to y first. Okay, now what?
Flip the x and y.
Interchange x and y, flip them. So far, so good? This is a 5-point question. Why? Well, because we have to use a little bit of, for solving purposes, we have to work a little harder. So I'm going to, frightened by fractions, I'm going to move that over. Ultimately, our goal is to solve for y. So distribute the x through. 2xy plus 3x equals 6. Subtract 3x.
Divide by x.
Or divide by x first, if you want to. All right, make life easier. Divide everything by x. So we've got 2y plus 3 equals 6 over x. It gives you the same result. Subtract 3, so 2y equals 6 over x minus 3. You know, my worry is how do you handle that 2?
How'd you put the x on that side and the 6 on that side?
Well, the 6 stayed. I brought this guy up here. I multiplied. I really cross-multiplied, really.
What if you distribute it through?
Oh.
What if you distribute it through and then just divide?
It's a little easier if you did for math, like visually.
Yeah.
But either way, it does the job. Yeah. Yeah.
Yeah.
Yeah. So they're saying, what if I distribute it through and then solve for y? Visually, it's a little easier to see what you're supposed to do. Like now I know I need to divide by 2, which is also known as multiply by 1/2. So you have to remember that I'm multiplying both of these by 1/2.
Mm-hmm.
Right? So if I did that, I would have everything multiplied by 1/2 is going to give me y equals 6 over x times 1 over 2. It's actually going to give me 3 over x.
Yeah.
Okay? Minus 3/2. Okay, and I said that. Yes, you would have. Yes.
Because multiplying both sides by 2 would be the same as, or no, dividing by 2 on both sides is the same as multiplying by 1/2.
Correct. So we end up with 3 over x minus 3/2. That was just like step 1. What's the next part want me to do? Set them equal to each other. That's why this is a 5-point question. Because it's multi-parts. Okay, so what we have going on is x minus 2 over 3 equals 3 over x minus 3 over 2. Do you think we should use this version of the inverse of it?
Yeah.
Probably, yeah. Okay. Since it would... All right, what do I do? This is a good algebra skill. I would get, bless you, I would try to get a common denominator all the way across. Because once I have that denominator all the way across, I can get rid of it.
6 divided by 6.
Multiply everything by 6x. That's exactly what I would do. So if I multiplied 6x times 1/3 x, do you agree it's 6 times 1/3, which is 2, and x times x, which is x squared? That was pretty. Then 6x times negative 2/3. Does everybody remember how to do it pretty easily? 12/3 really, or 3 goes in there. So what's 12/3? 4, and then there's an x that tagged along, right? And then what happens here? We've got 18x over that, so really 18. The x's cancel. And then over here, we've got 18 divided by 2, so minus 9, and the x is there still. That's easy to work with. It screams.
How much
I'm a trinomial set me 0 factor. Yeah. Bringing me all to one side, right? So add that, I get 5x. Subtract that, 0.
Wait.
Okay. No wait? All right. And then you factor it however you feel comfortable. Berry method. Count on your finger and toes method. I don't know.
Can you do the berry method really quick?
I don't remember how to do that.
It's really simple.
Okay, it's really simple.
2 by 18. Here, you get it.
Okay, so you get 2 by 18 and you get 36.
Then you just try and figure out what two problems when you multiply, what two variables multiply and equal 5. So like, it's actually negative 36. So it'd be like, there's 6 and there's 5.
9 and negative
9
4.
and negative 4, yeah.
9 and negative 4.
And if they, when you add those together, you get 5. So
Yeah.
those would be your two problems. So you have 2x minus 4, and then 2x plus 9.
Why do you use 2x twice?
Because it's the very method, and then you FOIL out from there. That's the way
So
to
they cancel out.
The 2 out.
Because you put the 2, when you multiply the 2 times the 18, you added in an extra 2 that you don't need. Now you have to factor out that.
That sounds like a lot of
So
work.
you're going to factor out the 2, so it'd be x minus 2, 2x plus 9.
2x minus 4.
It's just an extra step. It's pretty much what you do. Just we have an
Just
extra step.
And then
So it's x
yeah.
minus 2.
So that's the answer.
So you
That's
factor
how
out
you-
the first 2?
The one that has
It
2.
depends on if you can. Sometimes
Oh,
you
if that's
can't.
like a perfect square thing? Like that?
You know, it's just,
No.
you can factor out the 2.
It's
Because
2 goes into
the
4, not
original 2,
Oh, so you just
put an
pick.
extra 2 in it at
That's
the
kinda
beginning,
weird.
so now you have to just take the 2
Okay,
out.
so the old lady method is you go, okay, 2x and x make that. That's how there's a box method too.
What's that mean?
Okay.
I don't know.
I have to think about it. I mean,
Quadratic formula.
it is kind of sort of. It's like this, and then the box method. Right.
I didn't get that far.
Yeah, you say, okay, what are the two
I
things
did like
that
the same thing
multiply,
over
right?
and over again on
So-
Friday, to be honest.
So like this guy is 2x squared. So what are the two things that make up 2x squared? 2x and x, right?
Mhm.
Yeah.
And that would go.
Somewhere.
It's like 2x and
Oh, I remember this. It's on the bottom.
here. I don't remember. I have to think about it.
Well, if all else
Do
fails,
you remember? No, me neither. Okay. If all else fails, go with the
Quadratic.
old-fashioned method like I do. I don't know.
or quadratic, I meant.
Quadratic formula,
Yeah.
perfect. Do that. That'll work every
That's what I'm
time.
going to do every time.
Yeah, it works. You know. Okay, so anyhow, long story short, you have an answer here, which you guys got with the Berry method, and so the question itself said what? Solve.
Yes.
So they're looking for x values.
Which one are we doing?
It was the
I,
first
I.
guy. Yeah, we're at I. Are we good? Are we looking for x and y values? Quite possibly. Solve. So, just x. Okay, we're good. All right, so do you see how these are approached? They're not bad, right?
One problem.
One problem. It is, but listen, it was worth what, 5, 8, 9, 10, 11.
Oh, that's true.
And remember,
That's like a quarter. Of a point.
right?
How many
So-
do you typically need? To get like
42.
About 42-ish. Yeah. Yes.
Are you finished doing problems
Yes.
or? Okay. So I can stop.
Yeah, you can stop recording.
need
Yeah,
like in
sure,
this
keep
class
telling
for it to
yourself.
count as you passed? Higher than a what? Like for a passing grade for high school graduation.
A D or above.
Okay.
Okay. We're good. No
I think I have
worries.
61.
You're okay. Okay, this one says given two functions. Remember they're written kind of weird. But you know we just rewrite them the way we're accustomed to. Find the values of k for which f of x equals g of x has two equal roots. I'm on May, June 2006. Find the value of k for which f of x equals g of x has two equal roots, and solve the equation in these cases. This should ring bells and say two equal roots. Oh, Ms. K told me it was going to come back. What does that mean?
The B minus 4AC.
We're going to be working with the discriminant. Okay, there are three scenarios.
Oh, I forget.
No roots, less than 0. Right?
Yeah.
Right? Two equal roots means the same root repeated, also known as repeated roots. So two equal roots is equal to 0. And then two roots, two distinct roots, is going to be greater than 0. So this one's referencing which one? B squared minus 4AC has two equal roots. So it's equal 0. So it says find the value.
Why did you do b squared minus 4?
Because when it starts to talk about equal roots, that was when I think it was chapter 4.
Yeah.
And then I said, ooh, we're going to do it again in chapter 5
Okay.
because we did inequalities. And then I said, I promise it'll come back. And here it is. Mm-hmm.
So that's the inside part of the quadratic formula.
Correct. Right. Because if we think about the logic behind the whole thing, negative b plus or minus the square root of b squared minus 4ac all over 2a, right? This thing is a quadratic formula. It does great things. We've been talking about it today. Okay, let's break it down a little bit.
That's
This thing,
just the root part.
that's just the discriminant part. The square root, what do we know about a square root logically? It shouldn't be negative, right? It should be positive.
So it's negative and has no
Right.
roots.
So if it's negative, that means it doesn't exist, it's imaginary. So no roots, right? Okay, the next one is if it's equal to 0, that means that whole thing is gone. So what's left is just this. And what was this again? Do you guys remember?
Oh my god.
Complete the square or
This is kind of mind blowing right now.
oh,
When you
Yeah.
do
axis of symmetry.
Right. This is your axis of symmetry, which is the x value of your vertex. So if there's nothing here, that means that it's just the axis of symmetry that just hits on it once. We're good to go, right? And then the last but not least is the one where it's greater than 0, meaning this is positive number. So then we would do negative b plus some number and negative b minus some number and get two distinct answers.
that's kind of
So that's what that whole thing is about. And that's why this thing is quite important. Every time it talks about roots, this is what it's referencing. Also, when it talks about x-intercepts, that's what it's referencing. So this thing is really handy. It does a whole lot of stuff for you. And knowing that you have it right there on your paper, you don't have to memorize it. Just remember that this, whenever they start quoting the word roots, you know that's what you're going to use. So we're going to set them equal to each other, right? So we're going to set them equal to each other. And then we have to make it look like ax squared plus bx plus c, right? We want to get it to look like a quadratic. So I see a fraction, don't like it, so what am I going to do? Multiply. So k minus x becomes one quantity, and there's that. Everybody okay? What do I typically feel, entitled? What do? I just FOIL it. I feel like I should FOIL it, I'm going to FOIL it. So I have kx plus 2k minus x squared minus 2x equals 9. Are we okay? When we're working with that b squared minus 4ac, I wanted to get it into the form of ax squared bx c. So my squared comes first. So negative x squared I put the things with x's together, so plus kx minus 2x. And then I put the things with no x's together, so plus 2k minus 9 equals 0. Our job is to get b squared minus 4ac equal to 0 because it says 2 equal roots. The other wording for that would be repeated roots. Okay? So, okay, we need b, a, and c for this whole thing to work. So let's label it out. What's a?
Negative
Negative,
1.
just the no x's, right? So negative 1. Everybody cool with that? What's b?
K minus
K
2.
minus 2. And that right there would be the normal thing that trips people up. That would be the one thing that people make mistakes on. Yes?
So, but it's always the first 2, like if you've got, or it's whatever x is.
It's whatever attached to x. So
Right.
if you have a string of things attached to x, you just take those numbers and string them
You
together.
would factor out an x. And
You would
then that
factor
would
out
be
an
the
x.
coefficient that goes in front of x.
Never mind. Answered it yourself. Yeah, because if you look at it this way, which is what Ryan just said, factor out the x, what's left? Well, k minus 2. Okay, and then what's c? 2k minus 9. Are we good? Okay, so now, we're going to take and use these three things into b squared minus 4ac equals 0. So b squared, so k minus 2 squared minus 4 times a times c equals 0. And it said, find the value. Just say find the value or values of k. With an s at the end?
Yeah.
Yeah. So,
Wait. Oh, I'm looking at them wrong. Okay.
so we should be actually finding values of k. So I'm going to FOIL this guy out. I'm going to take, this is really, do you agree, positive 4? I'm going to take positive 4 and distribute it through. Okay. So positive 4 times 2k, so plus 8k. Positive 4 times negative 9, negative 36. And what does this scream? I'm a trinomial factor. Okay, I want you to go home today, finish this particular problem if you can, and do pick 2 to do. Okay? I moved